All right, welcome to the first video demo of Gearify 2.0. What I have here is the start screen when you basically open the software. In the finished version, before you get to this screen, you will have some sort of a designer selection menu where you will indicate what design method you want to use. But right now, since I only have the free draw editor implemented, it just begins at the free draw editor start menu. So first of all, before you actually get to drawing your input gear, there are several options to describe the general structure, symmetry, and characteristics of the input gear that you're trying to design. And these options are dynamic. They will make various options appear or disappear depending on whether or not they're appropriate. But for starters, so I have close versus arc gear, which is hopefully self-explanatory. The radial symmetry of the gear, which is how many divisions. In this case, I have an icon showing an example. That would be a symmetry of 8, but you can do any symmetry up to 12. Whether or not you want bilateral symmetry for each lobe, and whether or not the gear is smooth, which is a nice smooth closed loop, or whether or not it has any sharp points or discontinuities in it. So let's start with the default options. So basically, I have via mouse and keyboard inputs the ability to basically drop spokes. And this is a natural cubic spline right now that is being traced around the control points. And I can basically make whatever shape I want. Now, notice I can, even after I drop a spoke, I can select it by clicking on it. And I have keyboard shortcuts to delete it. I also have the menu option to delete it. And likewise, when I have a spoke selected, I can actually get in here and fine-tune the exact values that I want, and it will directly modify them precisely. So you have sort of this duality between the viewport and the user interface, which is usually pretty powerful. Yeah, so this was just a basic, sort of random gear design. But let me go back and suppose that I have a 3 symmetry gear. So I'll just change the radial symmetry to 3 with all the same other options. And now, basically, I have this 1/3 sector to work with, and any changes I make to the 1 sector will be duplicated and copied in a rotational fashion. See, it's almost like a propeller type shape I have right now. And, I can kind of play with it and modify it to be pretty much any shape that I want. But one thing about this is that notice that there isn't exactly any right to left symmetry along this lobe. This side is slightly different. This half is different than this half. And the question is, what if I want a nice even symmetry where maybe there's like some symmetry about the center line? And for that purpose, you can select bilateral symmetry. Bilateral symmetry doesn't actually mean it's down the middle of the gear in general. It actually means it's down the middle of any particular lobe of the symmetry. So because this was a 3-fold symmetry, I basically have 1/6 of the circle to be my edit region. And anything that I do here will be reflected about this other side. So I can just grab this point, for example, and very effortlessly I can create a very nice symmetric shape that's not only radially symmetric but bilaterally symmetric about each lobe. So that's really quite powerful. I'll go back. So yeah, and you could do, say for instance, a symmetry of 1 with bilateral symmetry. This usually makes very nice and aesthetically pleasing gear shapes, just like a nice 1 symmetry. like so. I'm kind of failing to make something that looks the way I want it right now. That's a bit better. Just trying to make some sort of random, pretty symmetric shape. So yeah, and you can choose any symmetry. You can decide if you want it to be bilaterally symmetric or not. But then there's also the arc gear design. Now, as you can see, if I change to arc gear, my options change a bit. So this is my sector angle, which is how wide the opening of the gear. So this is a gear that isn't necessarily closed. So I'll start with the default option for now, and that would be a 60-degree opening. Let me turn off bilateral symmetry for that one. So this gear, as it's stated, it doesn't have to be closed. It's just a specifically open arc. So this wouldn't be something that would do a full rotation, but would probably oscillate back and forth as it mates with the opposite gear or gears. And, the controls are quite similar. And finally, if I go back over here, there's a somewhat more advanced editor to create discontinuities in your gears if you're interested. So this would be, for instance, how you create something like a spiral. So the way this editor works is that in the smooth case, you have just one single curve that you're editing and always remains closed and always remains smooth. But in this editor, when you have the sharp option checked, I notice it actually gives you a little iconography to remind you what options you chose here, and you can mouse over them to see what they were. So in the case of the discontinuities selected, there's a control basically to split your shape into a number of segments. And the idea is that the boundaries of these segments are where the discontinuities and sharp corners can occur. But within each segment, you have to have a nice smooth curve. So I can double click on each of these segments, and then I go back to my traditional spline editor. And I'm not trying to actually explain how all of the interactions work. This isn't really meant as a tutorial. It's just meant to show you what it can do. Later, I'll post the tutorials when the software is actually released so you understand how to do it. But the idea here is that now that I have multiple segments, I have the means to create sharp corners, which you couldn't do before. So this does create some interesting problems with if you want to add teeth to these gears, then you have to have some kind of custom sort of intervention to try to connect up the teeth sort of somewhat manually. You have to take some effort to kind of close up the seams, and there will be tools to help you do that. Which is kind of annoying and complicated, and something I'm trying to somewhat deprioritize for the near term, because I think this is more an edge case that people would want. But because I'm trying to make the software more robust and be able to handle the more tricky cases, I mean, that's what the software is supposed to help you with, is to do the tricky stuff. But notice here I can actually fully disconnect the segments and create jumps and actual discontinuities in the shape. So there's no actual rule that requires that everything be a smooth curve. It is trickier to get the gears to actually work. In this case, you have to, look at the specifics of what you're doing, and it may work or may not depending on how extreme you do it. But people have made things like spiral gears. So let me just show you, for instance, if I go back and clear my design, a spiral gear, all I have to do is have one segment and just relocate the endpoint. And voila, you have a spiral gear. Likewise, I could also say symmetry 3, and I could have a repeated spiral, like so. Cool. So that's basically the editor, uh, broad strokes. Let me show you now actually creating some gears, or at least some pitch curves generated from these shapes that I'm drawing. So let's start with a nice, even, symmetric symmetry 3 bilaterally symmetric smooth curve. And let me just create a nice, basic, uniform triangle shape for us. Finalize. Next. So this software, there's a lot to do with the UI still in terms of making it clear and intuitive with all the UI widgets. But the idea is that it's going to be like a workflow where you're going to move from one step to the next and basically use next. Once you finish each step, you proceed to next, and there will be some little, indicator to show you how far through the workflow you are and what stage of the workflow you are. So it should be much more clear than version 1 to kind of walk you through the steps one at a time. And there will be lots of tool tips and little text hints and everything to tell you what it is you're supposed to be doing to help guide you through the process. So ideally, it won't even be that you have to read a manual. Ideally, it should just walk you through the process and be very clear and intuitive right off the bat. Okay, so here is step 2. And if you watch the first video, this is the compute mating pitch curves stage. And what's cool about this is that I have basically my input pitch curve filled in over here. This is considered gear A3, which is a 3-lobe symmetry. And there are all these other slots available. And notice that there are 2 columns of gears. And if you want an external gear assembly, you want a gear in column B. So if you want an external gear connected to this one that has a 3-lobe symmetry, I would just click the plus symbol on this column, and voila, you have a mating gear of symmetry 3. But likewise, let's say I wanted a mating gear of symmetry 1. Can just generate that guy. Or of symmetry 2. And so on. It can be whatever you want it to be, and I can just add or remove them quite seamlessly. But likewise, I can also choose other gears from column A, and watch what they do. If I choose a 1-lobe symmetry from column A, now I have an internal gear assembly. This is actually rolling on the inside. So this, you could imagine the teeth being on the inside of the shape on the interior, and you have a gear rolling in. So there are 2 separate interpretations of how you could actually use this gear. Likewise, I could have a 5, in which case now the input design is actually rolling on the interior of the gear that you generated. But it gets even weirder, or cooler, I should say. So I can actually simultaneously add these gears in pretty much any configuration that I want. And notice something kind of magic happens when you line them up this way. You realize that the way you pair up the gears is purely a matter of interpretation. Even though I used 1 gear to generate all of these designs, look what happens if I say take this gear, I'll hide the others, and pair it up with this gear. I have an external gear assembly where the one has radius symmetry 3 and this one symmetry 5. On the other hand, I can hide this one and activate these 2. Now I have another internal gear assembly. I can pair up these 2, and I have another external gear assembly. And you realize that whether it's viewed as an internal or external gear assembly, or what they're connected to is purely a matter of how you pair them up and purely a matter of interpretation. You can take any two of the gears that I've generated and pair up literally any two of them, and they will mesh. That's part of the reason I did it this way. But each symmetry value comes in two flavors. There are two types of two symmetry gears. You can see those are slightly different. This one has a concavity and that one doesn't. There are two types of three symmetry gears. So there are two columns for each type of to represent each of the two types for any symmetry value. But they just work. You can pair them up any way. You can pair them up any way you want. So this is why I actually created this two-column assembly, because you actually create this whole family of gears that you can connect any way you want. And later there'll be an editor to basically choose what you want that interpretation to be, internal or external, and what you want to pair up with what. Lastly, over here we have a rack gear. And this is essentially the result of, imagine if you had a symmetry that was infinitely large, or an infinite radius. And because this is sort of like infinite symmetry, you can basically have as many repetitions of this as you want. Well, not quite as many. I limit it to 12, but you could copy paste it once you export it and just have as many repetitions as you want. So this is the rack gear. Imagine, as if the center of rotation was an infinite distance away. So that's very nice. And what's actually really cool about the rack gear is watch what happens if I turn all of the available options on. So I limit it up to symmetry 12. And notice all those lines are kind of getting in the way, so I can uncheck the show support option to get rid of those little background lines. What happens is that you have all the column A gears on one side, all the column B gears on the other side, and the rack gear is always trapped between the two of them, assuming you have a reasonable design that doesn't self-intersect. And again, you can imagine you can take any two of these gears, any two, whether it's the rack, column A, or column B, and connect them up together. So you can imagine if you want to make a multi-gear assembly, you have a lot of power to create many different configurations, all from this same gear family. Cool. So let me go back and let me show you the arc gear assembly. So let me choose a slightly different value. I'm going to choose 279.8. I'm going to make it extra weird. And I'll leave all the other options default. Let me not do bilateral symmetry there. Okay. I'm going to choose this thing called end-to-end wrap, which basically makes sure that my endpoints match up, because that will let me to exploit certain symmetries. So I basically just modify the curve as I see fit. Whatever, I can do what I want. Kind of straighten that out a bit. Cool. Let me turn the support back on. So here's what's really cool about this interface. So now, instead of having options for the symmetry values, I have options to input a delta theta for my output gear, and it's the same configuration. These are internal gears, these are external gears. So let's say I want to make a gear that has a 180-degree turn that meshes with a 279.8 degree input gear. So I just enter 180, add it, and there it is. And what's also cool, because 180 is relatively small, I can have repetitions of that gear that will not exceed 360, so I can actually duplicate this gear. And look at that, I now have a 360-degree turn that pairs up with a 279.8 degree gear, input gear. Now, it may not actually be practical because this one can only spin one way around, but you could have maybe two assemblies on the opposite side, for instance, two copies of this gear opposed to each other if you wanted, for example. And yeah, I can have any input delta that I want has 33 degrees. And let me say let me add even 5 degrees. You can see that it's way out there because it has to be a very narrow angle that it's traversing, which is super cool. And check this out, I can likewise, even with the arc gears, I can include the rack gear as well. And it will perfectly mesh with that arc. And I can add repetitions to this guy as well. Lastly, if I back out, this last bit is a bit hard to demonstrate because I don't have really good visualization tools to help you see what's going on. But this is the other benefit of having an arc gear, and that instead of designing the gear by shape, you can design it by ratio. Now it's a little hard to tell because right now the editor is exactly the same, where you're controlling a spline shape. But in this instance, rather than the shape at any given value of theta, rather than the radius expressing or the distance expressing the radius of the gear shape, the radius actually expresses the ratio that you're interested in achieving in the torque or in the velocity ratio between the gears, which effectively gives you your power transmission curve, which would vary. So I've indicated by shape on this, I've drawn a curve. I'm going to say finalize and go next. And now in this case, two gears are spawned that it should actually fill out. That's something I have. Oh, I guess it's up there, 245.40. So this case, you don't have options to add other gears because there's only one gear pair that satisfies your conditions. But this shape that's coming out is not the same input shape that we specified. It's actually a slightly different shape because this gear assembly is a gear assembly that basically nails the appropriate power transmission curve based on the input that we described. And the reason it has to be arc gears is because once you specify freely a transmission curve, the rotation ratios are going to be whatever they're going to be. So they can't be closed gears assemblies in general. Likewise, you can also, if you have, well, these are too big, but if they were small enough, you could have a repeated copies of the gears if you wanted. But this is a much more powerful capability that you can get from the arc gear assemblies. So yeah, and that's I guess that's about it for those are the major details of the current demo in terms of what can be demonstrated. I do want to just kind of go back real quick and let me see, where am I? What am I doing here? want to point out real quick a detail that I forgot to mention. I just want to be clear that with this 2-column assembly, what you can do is any 2 column A gears, your design gear is always a column A gear. And any 2 column A gears can always be paired up to form an internal gear assembly. Likewise, any 2 column B gears can always be paired up to form an internal gear assembly. And any column A gear can be paired up with a column B gear to form an external gear assembly. And likewise, any gear at all can be paired up with the rack/rack and pinion type gear for an external gear assembly. This one or that one. So, all right, well, I hope you enjoyed this demo. Next month, I hope to have some demonstrations of the actual tooth calculations being shown. But as you can see, there's a lot you can do with the pitch curve design with the symmetries. So I hope you enjoyed this video. Please post your feedback, and rest assured there is a lot more to come soon. There's a lot more in the works. So thank you for watching.